Welcome back to Stationeers, and it's time to build our proper furnace setup. Fed up of using arc furnaces? I am pretty much now, although they are useful for some things. They do release stuff straight into the atmosphere, so it's kind of useful. However, we're going to want to do something a little bit better. So, I put another pipe here, at back, and it's going to lead all the way down, underneath, follow it along, and it heads into the bottom floor of our base. The underground section anyway. And here we've got a furnace. It's pressurized at the moment because I've just made some steel, but there's nothing actually outputting. The end of that pipe is actually sealed off, so it's not going anywhere. It's still stuck in this. Let's just turn you on and you'll see what I mean. So we've got 109 moles of CO2 and we've got 101 of pollutants. That's the bottom left X. And little bits and pieces that we might be able to recover. O2, some N2, some H2. Its temperature sitting at minus 19 degrees C now. But it wasn't when I started this furnace up. It was much worse. So we've got to, it was, a few hundred degrees C. So we've got to deal with that somehow. And before I do that, I just want to hook up this input, because we haven't used the gas input options for this yet, but we can now, because we can mix the gases upstairs. So let's pop that down. We don't need you for now. So if I have some fuel, I can put here, and in fact I don't want it quite here. I want it a little bit further up, because I'm going to need a valve. One of these will deconstruct. There we go. So I can't put it there, can't put the valve there, so I'm going to need to put it there. Yeah, we can still reach it, but it's the input for this furnace. And we're going to want those pipes back. They rolled. Okay, so we're going to want to put the the valve. Do I have a valve with me? No, that's not a valve. We need to make a valve. Let's just drop you down here. Let's go and make one. And we'll be able to control that manually at first. But later on we'll want to, computer or logic control that. Let's get ourselves a valve. Hopefully I've got enough materials to make it. It's probably going to be copper I'm going to be short on, if anything. So, pipe, pressure regulator, nitrogen, oxygen. Not a digital valve, I just want a regular pipe valve. I'm short on copper. Is there any other machines? No. I'm going to be completely out. Okay, I'll build the input later. Let me just finish off the output then. So on the output, we can just put a passive vent in, right there. And it will happily vent out all of that gas that I've built up. However, I may only want to do that if, and when steam stops making noises, if it's cool enough. Or, as a safety feature, if it's too high pressure. Because if it's too high pressure, pipes will rupture, bad things will happen. So I'm going to change this to back pressure regulator instead of normal. And we're going to rotate it. And other direction, flip it over. Still did the direction. Well, I will get it correct one of these times. Okay. Okay, it's now hooked up now that I've got this rotation. I'm so used to space engineers. Anyway, we need more pipe to connect that up. But before I connect the pipe up, what we want to do is set this to 9,500, and there's a lot of clicking there, but it only needs to be done once. So essentially, if anything in any of these pipes reaches that, before they rupture, it's going to open this valve. And the way a back pressure regulator works is instead of pushing it all this side, it doesn't push until the input side reaches whatever pressure you set. So you can use this as a more automated dump valve when the only time you want to dump is when it gets to high pressure. And we're just going to get that up to 9,000, I don't know, 9,500-ish. Let's give it a bit of room just so that it can increase a little bit on this side while this is actually activating. Now, of course, I need to power this. This isn't just an automatic thing. It's a shame because you can imagine you could build a spring mechanism or something that was strong enough, but it wouldn't be configurable then. Yeah, so it will do just fine. Let's go and grab those pipes. Where are they? Ah, they've rolled away again. Oh, there you are. Fine. Oh, and we may as well build one. Oh, it's the valve. Never mind. So up we go. And then what we probably want here is a T-junction, not anything else, because this is just an optional thing for safety. So let's just make sure we're on T-junction. And back to straight. Okay, there we go. And then this side is going to be wherever we process things. So I think I'm going to start by changing to some pipe radiators, make them in the hydraulic pipe bender. And we're going to do that and rotate them. Let's just actually go down there while we put this in place. We'll bring them down and we'll put them onto the pipe itself. And these are going to cool down whatever's in the pipe by radiating it into space. And of course, there's no convection, no conduction, because it's vacuum out here. So the only way we can do this is with radiators. They don't seem very big, to be perfectly honest, to do that job, so I may need more. They do actually work, however. I have had this pipe being a couple of hundred degrees, and these actually do cool it down. However, they don't cool it down fast enough to just really immediately dump this back into the atmospheric room, which is what we've got around here. So what would happen is, if I had it in the atmospheric room, we'd probably provide it as an input to this pipe, and it would go up through the filtration system and then down into these pipes and separate it out. And as you can see, we don't have very much carbon dioxide, and we have next to no pollutants, which is out here. Yeah, nothing. So what I don't know is if this will all survive several hundred degree gases going through it. But we can try it. There's no harm in doing that. And also, I guess what we could also look at is up here. Because if we provide this as part of the input to this first one, that's the output. So we could bring it all the way up here and into the input. We could still put more radiators, which will chill it all the way down, and then see where we go from there. We ideally don't want to do too much furnace work, and I don't want any of these pipes to rupture, but it will be this first unit that will rupture, if anything, I would have thought. So why don't we try that? Do I have enough pipes? I really don't. I'm nowhere near the top yet. So let's just pop you in place. And build a few of you. And then let's go and get some more pipes made, shall we? I could make them from the fabricator, but this is just closer. Construction kit pipes, are you going to be on there? Probably not. There we go. No, we've got enough for 50 pipes. We're not going to need anywhere near that much. But 10 should do just fine. And then, you know, we've got everything set up. I do need a valve, though, which means I need to go and get some more copper the next time the sun comes up. I could do a floodlight or something along those lines. I've taken the light off from up there. I was originally expecting to use it as a beacon. However, the level of distance, the level of detail thing doesn't show lights very far away at all, where it shows the structures really quite far away. So for me, it was more worthwhile to have that off than anything else. I can see this structure pretty plainly as long as it's daytime, and not too bad if it's nighttime. So let's just turn you off. And let's see if we can complete these. Turn the jetpacks back on. And, you know, we should have room to fit plenty more radiators if we need them. Obviously, I'm burning through my my jetpack fuel. But that's okay. Let's just grab a corner. And another corner. And I suppose what we could do up here is have yet another valve of some kind, you know, something to control this, to keep it sane. but I'm going to take a save and because it's so early access, I don't want to accidentally break everything. So I do want to do some testing, and I would advise you guys to do this exactly the same. So there we go, and instead of being let's just change that. Instead of being a corner there, we'll just change it to be a T-junction. That should do the job. T-junction. Rotates. And there we go. So that should now be hooked up, and it should already be filtering into our system. Remember, the gas is quite cool, so let's just grab our atmospheric analyzer. Pipe network is 0, nothing in this at all now. And this is going through. You can see all the filtration happening. Look at the bottom right of your panel, of my panel even. See all the... Have you gone through? Yeah, you've all been pulled through here, through here. And this one is just now pollutants. So we do have all of that stuff. Should be in there. Let's just put you away. Yeah, we've got pollutants, and we've got a large tank full of water that is going to build up until I deal with some other way of dealing with water. So that's fine, and then we should have, again, still pure in here, nitrogen. Oxygen's getting a little bit high. So what we may have to do in this system is either have some kind of bleed off to a larger tank, which is a possibility, or again have that same kind of safety valve system, the back pressure regulator, that if these hit 9,500, it will dump to passive out to space. I'd prefer to have at least a much bigger tanks, and this room isn't big enough for it, but these are more than adequate for the moment. Which one's that? Is that the hydrogen? Yeah, so we can always get more propellant if we're going to use that for that, and then again, pretty much not much CO2 yet. Okay, so that is the output side. We want to have the input side as well, and the input side we're going to have to mix hydrogen with oxygen. Let's just check these pipe networks. That is 77 moles of oxygen. So that's input 2. Input 2 is on the oxygen side, so that's fine. So the hydrogen side is empty, which was the nitrogen side for air. And let's just take you out and let's see if there's anything in you. No, you're empty. So let's just get one of the spray cans, shall we? Let's paint it a dangerous colour. Blue. No, I don't want blue. I'm using blue for something else, I think. I did colour some canisters blue. Can't remember why. Let's see what other paint cans we've got. We've got a violet red, we've got green and yellow. Okay, let's leave it this colour then for now. Pop it back in. We've got oxygen, and we want that 7525. Turn this regulator on. And there's nothing in this pipe network. The valve to the dump is off. So we can turn the gas mixer on, the pressure regulator on. Good. So it's just needing hydrogen. Which is you, isn't it? Yes. Okay, so you should now be working. And you are. Hydrogen and oxygen. Pressure's building. Of course, there's nothing in this oxygen side. Or at least there's no actual canister, but it's still actually getting gas. And it's already out of hydrogen. Okay, so we can of course release hydrogen by just putting it into this furnace, dumping it into our system through using volatiles, and we'll get more hydrogen that way. Remember though that every time I take this canister out, we're going to get more hydrogen that way, just like the nitrogen, and we can get that mixed just fine. So that's 1700 kPa. And what are you up to now? Ooh, are we out of oxygen? We are out of oxygen. So now, hopefully, that should pressurize. Yeah, we're up to 2 megapascals. The canisters can take up to 10. But of course, this pressure regulator is only set to 9, so we shouldn't get too much of a problem. And yeah, up to 2.7, 2.8. How much is in these? Out of oxygen. No, still got oxygen. We're out of hydrogen again, so let's just pop you back. Yeah. And let's take the oxygen as well and refill you. And now, let's assume that this is our fuel. So we can pop downstairs and let's go through the airlock. Put some stairs in. So much more convenient. Is this going to stick if I'm out here? Don't think so. Good. And just in case, by the way, if you do get that problem, and I think easiest way to demonstrate if we get the problem, if I just step outside here and then cycle. Yeah, so will you cycle again? Yeah, now here's the problem. So because there's no pressure in here, these doors won't open. And because it's partly through the cycle, you can't open the doors. If you get the problem, step up to the window, look through, and you can cancel the pressurization. Or you can build another one of those consoles on the inside. Just a quick tip. And that's going to go into there, of course, but I'm going to need a valve, which means I need to go mining.
Okay, so I'm back from mining with lots of nice ores. Yep, this bay is working just fine until we have a sorter. Oh, well, the sorter sorting setup. One of those things. So yes, we've got silver and gold, and that's what we're going to use to test this furnace out. I've disconnected the back because I want a remotely activated valve back there. If I just put a pipe in there and I turned on this system, which I'm going to explain in a second, all the gas would rush in to the bottom and rush back out at the top. There's no kind of control in here for the gas. It would be nice if there was a built-in valve. That would be cool, but I don't know of any. I guess we could hook up to the power and data and see what we can see in there, but as far as I know, there isn't a valve in there. So that's fine. We can build in an external valve just without any problems. A lot of the more advanced valves and things like the pipe analyzer require more advanced materials, and that's how we're going to test this furnace out. We're going to make some electrum, which is why I've got some silver and gold. That's an alloy of the two. So to do that, we've got this 75% H2, 25% O2. And we can put it in here. Obviously, there's no pipe pressure at the moment. I've put a thing on there so I don't need the atmospheric analyzer. We've got a regulator here. But first of all, let's take a look at this. Gold, no. Copper. Where are you? Steel, electrum. Okay, here we go. So the pressure needs to be somewhere between 800 kPa to 2.4 MPa. Okay? And temperature between 700 K to quite high to 10,000 K. Okay, so what we're going to do is heat up this furnace. Now, you may be tempted to say, oh, pressure 800 kPa, let's just set it to 800 kPa. No, because this gas is cold here. So when it warms up, pretty much physics says the pressure is going to increase quite a lot, because we're going to go from room temperature, 270 odd, well, no, in this case, 290 odd Kelvin, up to hundreds and hundreds of degrees higher than that. So the pressure is going to increase quite a bit. So why don't we start with something quite low? So let's just bring that pressure down to, let's say, 150. So remember the pressure we've got here is quite generous, anywhere from 800K to pretty much 2.4 MPa. Okay, so we should be fine. There's about 8,000 kPa pressure in there. There's nothing yet. Let's turn this on so that you can see. Sorry, that is. Oh, it's rushing the pipe, so it's going to be low pressure. That's fine. So 600 kPa, so we couldn't get to 800 even cold, but that's not going to matter too much because this is going to regulate it back down to 100 kPa. Let's turn that pressure on, and we should see it starting to flood into the chamber, which is fine. Yeah, there we go. 150 is equaled out. And we're down to 357. So obviously the whole volume of the pipes and the furnace is going to bring that pressure down more than you might expect. So just, make extra. And of course, once we filter out, everything is going to go back into our filtration system. So we can push the button. And up it goes. You see, we're already up to 2,500 kPa. So let's grab the silver and pop that in. And grab the gold and pop you in. And it's smelting ingots of electrum. Out it goes. So now that's done. We've got lots of electrum, which looks pretty cool. It's is that a cylinder? Yeah, it is a cylinder. Cool. So now we can just vent this if we want to. I'm going to leave it there for the moment while I go and make some other stuff because, yeah, it's going to cool off. It's at 900k. In fact, let's actually just test to make sure this can actually deal with our filtration system. If anything explodes now, it's my fault. I want to see how good that cooling system is. So there it goes. All the pressure is just leaving the system. Oh, turn the pressure regulator off. I think I've lost most of it now. Oh yeah, I've lost 150 kPa. There we go, it's down to 0. That's off. We can shut this off if we want to, just as a safety measure. And then let's go and see to make sure, I guess, that our system hasn't exploded. I don't think it will have. We've got some pipe vents. I've not got the atmosphere analyzer on me, but I need to trigger this back pressure regulator. It's not powered yet, I don't think. No. But I didn't actually put enough pressure for that to be a danger, so that's no problem. And everything on top. Yeah, it's all still fine. It's all fine. Okay, so we've got a furnace set up nicely from gases instead of just trying to lob in chunks of ore. And we've got some electrum now. So let's just take a quick look at what we can build. We may not have been able to before. I think there is, we want all the various controls, don't we? So we want all the pipe stuff. So a pipe analyzer, you're going to need electrum, okay? And a digital valve, you're going to need INVAR. We haven't made INVAR yet, so that's another thing to maybe test our furnace out with. And a gas mixer, label meter, radiator, valve, volume pump. I think we've made all of those before. Yeah, so it really is just INVAR and electrum. All right, so we've got some electrum. Why don't we make some INVAR? Now, INVAR is more difficult to make than electrum. It's going to require much higher temperatures and pressures. So I've gone and hooked up the back pressure regulator just in case things go bad. Well, it shouldn't go bad in the pipes because they're not directly connected to the furnace just yet. But just in case I want them there. If the furnace explodes, then that will be me having a problem rather than my filtration system. And there's 42 there. That should be enough. Where's our base? It's over that way. You probably can't see it. Let me cut towards the furnace. So here you can see the example what we need to melt in the bare metal, the nickel, and you can see the pressures are pretty much really flexible. Okay, doesn't really matter much there. So a lot of the ingots are like that. You can just vary that the temperature is only needed, different ranges, but only the minimum. However, electrum, obviously we've seen. INVAR? Is INVAR in here? Iron, silicon, it's probably more at the start. There we go, INVAR. So pressure, 6 MPa to 7 MPa, which is why I hooked up that back pressure regulator. Temperature, 1.2K to 2K, and there's equal amounts of iron and nickel. All right, let's see if we can get our furnace up to that temperature. Okay, so we're back at the furnace, and it's time to bring this pressure up a notch or 10. 0 pressure in there at the moment. One note, don't put in your ores before you actually start this, because that will then sort of change the pressure in here. So if you want to get this right, or at least it works for me, and hopefully it'll work for you guys, bring up the regulator to 350 from 150 for INVAR. And then you want to open the valve, and we're going to pressurize. Up it goes, and it'll drop back down in a second, because this is going to regulate. And here it comes into the furnace. That's going to go up to 350, so you want to get your ores ready, but don't put them in just yet. You have to be a little bit quick with this, but it's not too bad. So remember, we want 6 to 7K. Was it 6 to 7K? Is it reset? Yeah, why are you resetting? Stay on the same screen, remember. 6 to 7K and 1.2 to 2K. I'll leave that on. Are you pressurized? You are pressurized. Okay, so we can shut this off. We don't need any more coming in. And we can hit activate. And round that goes up to 7K. Wait for it to come down. There it is. So we just pop it in the top. If I don't miss. 1 and 2. 2. It's going to feed those in, and it'll convert into Ingar, pull the thing, and we get Invar. Good. Now this is going to be quite hard, quite hot, and I'm not going to want to connect this to this until it's cooled down a little bit. So again, the same thing before. It won't trigger the back pressure regulator because its pressure is still too low, but it's quite high temperature, so we can let that cool off. I guess we can smelt some other stuff if we want to, but I've got some Invar, and I've got some Electrum, which will let me build more of the advanced things, and things like digital valves and pipe analyzers and lots of nice things like that. It doesn't take very much Electrum and Invar either. So let's go and build a couple of those things, shall we? 1 and 2. Pop them both in. And now, can we build... what are we looking for? So, back we go. Digital valve. I'd like to see one of those. I haven't seen one before. That won't take a second. And we also want pipe... I don't think that's the way you spell analyzer. But then I'm English, so maybe it's spelled differently in other parts of the world. So a digital valve, okay. And we didn't want one of those as well. Ooh, fancy screen. That's quite nice. So yeah, we got this powered, which means that hopefully should have data ports, but you know, we'll see. And then what we also want to do maybe is deal with the analyzer and do something about that. So let me go and set a few things up. I'm going to have to route some cable down here, and I don't want that on camera. Be right back. Okay, so we're going to be doing some circuitry, which I'll explain in a second. I've got the pipe analyzer and the digital valve on there. Okay, so this turns on and off by computer or by switch, however you want to do this. The digital analyzer lets us see what's in the furnace. So we can see the temperature is falling, but the pressure is pretty much vacuum. And we've got a switch over here. Now, this is going to be a dump switch, but it's not going to be a dump switch. It's going to be a safety dump switch. At the moment it's on, so I need to rename this. So as soon as I flip it to off, or I could change around the logic, but either way, as long as this is on, the furnace is going to continue to work. And when I turn it off, then it will wait until the temperature is below a safe amount that we set, and then it will dump. Okay? So here's how it all works. Simple? Well, it should be. Let's just go through it, okay? So we've got a logic reader at the top that's reading, if we renamed this to the furnace analyzer display, and we've got the furnace dump valve here. Okay, so I've just relabeled them. So this logic reader is reading in the furnace analyzer. All right, and it's there. You can see it's status 376. That's its temperature because we set the variable to temperature on this side. Over here, we've got a bit of memory, and all this is doing is storing a value of 600. I'm saying safe temperature is 600. You can set this to whatever you like. Okay, both of those are being compared, and that's one of the logic processors. You just rotate with this scroll wheel. We compare input of the furniture temp reader, which is this, with this, which is the only thing that can connect to it. That's why there's only one cable, so we don't have to go through lots and lots of things. And I may actually put an APC up there just to disconnect this subnetwork from everything else, because it's a pain and a hassle going through all the things it wants to read and write to if you don't do that. So do consider that for your own network. So here we're going to say, compare these two, and if we're going to do less than, so if the temperature is less than 600, output a 1. All right. So over here we've got a switch that's currently outputting a 1, and this is reading it, and called the safety dump reader. All right, so we've got a 1 and a 1, and then we're going to do a compare here of those two things, saying less than. So if the safety dump reader, if that switch is set to 0, and this is set to 1, then you can output a 1, effectively. And this writer will then output to the dump valve, saying, if this outputs a 1, then go and turn on the dump valve. All right? So what you might be tempted to do is do an equals, but the problem with equals is that if this is 1 and that's 1, it'll dump. And if this is 0 and that's 0, i.e. the temperature is higher than 600, it'll still dump. So please don't use equals. Do use less. And you can easily see that it's set to 0 at the moment, which means that valve is off.
All right, so the temperature inside there is 0. Sorry, the pressure is 0 at the moment. So we can test by just flipping this way. And I guess I should rotate. Oh, I can't rotate the valve. It's only one way. But yeah, you can see that the dump valve turned on. All right. So if I turn this back that way, and we do a little bit of a test. Okay, yeah, we got some pressure in the system. Let's just turn on the regulator. And you're increasing up to 50. Yep. Turn off the regulator just so we don't have the continual flow going through. Let's turn the furnace operation is set on at the moment, so we can turn this on. And are you dumping? Why are you dumping? You're higher, you're set to 0. You shouldn't be dumping. Good. So pressure is going down, but so is the temperature. It's actually staying in there because that valve is still off. And it will remain off until I tell it otherwise. So this is set to 0. As soon as this, in fact, let's just actually fix this by saying the safe temperature is 700. As soon as that passes 700, this will turn to 1. There we go. The comparison is still 0 because this is not less than 1. So we still shouldn't be dumping. I don't think we are. Let's go and look at the valve. No, we're not. So I'll set this to decrease back to 600. It's just past 600, so let's say 500. Yeah. Let's go and turn this off now. So I'm finished with the furnace. It's not venting until this reaches 500. So let me just set this back to 600 again. Now it's venting. Okay, completely safe furnace system, and it will also let you set everything up so that, you know, you can set a pressure, you can make your ores, or your alloys in this case. This is my alloy furnace at the moment. We'll do sort of like automatic ore furnaces, I guess. The only problem is you can't really use the ingots to make the alloys. That's a bit of a problem at the moment, unless we put them through a recycler maybe. We'll have to look at that next episode. However, we have a furnace setup which is working pretty well, I think. Yeah, it's still venting out to our filtration system, which upstairs is then going to reprocess everything, and we're done, I think. All we have to do is just seal the wall back up again, and I have less iron sheets than it takes to seal up this wall. Where did I put my iron sheets? That's a mystery for another day. For now, I think we're done. So, if you enjoyed this episode, feel free to thumbs up, give it a subscribe if you haven't already, or share it with other people who might be interested in setting up automatic furnaces. Why wouldn't you be if you like this game? Thanks for watching, and we'll see you next episode.